In this video, we're going to get started on the needle valve. This drawing and a JT file of the needle valve are available on the website. I'll link to that in the description. But we're going to get started with the main body of the valve needle. And it's going to look, when we get done, it's going to look something like this. So this will be sort of the core, and then we will add features to this later on. So as we develop our modeling strategy, we'll look at different ways that we could model this. We could model it as maybe a series of circles that got extruded. But I think it makes a lot more sense in this case to model sort of the profile of this. Notice a lot of dimensions on this view. A lot of the profile view is dimensioned. And so what we're going to do is create sort of the exterior profile here. So we're going to have a sketch that follows this path. And we're going to include the taper on that. And so this is kind of the general shape that we're looking for, and then we're going to revolve that shape around. To get started, we'll say File, New, and we'll make sure that we're using a millimeter template. We're going to give it a name that has some meaning to it, and we're going to put it in a location where we'll be able to access it later on. So we'll say OK, and what we want to do is start a sketch. So we'll come up here to Sketch, and I'm going to make it on this XY plane, the top view plane. I'm happy with the horizontal axis, and I'm happy with the origin. Now to do most of this, I'm going to use the profile tool. So a lot of different sketch tools up here. Profile is a pretty handy one. I'll just show you a little bit about that. It's useful for making a series of connected line segments. You can also mash down on the mouse wheel as you come off of one of the endpoints. And so by mashing and dragging, you can create these tangent arc segments. So profile tool, very handy when you have a series of line and arc segments that are all connected end to end. So like I said, I'm going to start the profile tool. But before I do, I need to kind of talk about the origin that I'm going to use. And that will come from basically from the print. So on the print, you can see that a lot of this is dimensioned down here from this end, and so that is what I'm going to use as my sketch origin. Alright, so profile, and I'm going to originate here on this side. Now what I'm going to do is just sketch the overall shape of the profile without really paying any attention to the size. I don't really need to get the proportions right. I just sort of need to get the schematic right, and I'm going to try to sort of approximate the proportions. They don't have to be exact at all. Alright, so this part comes out, this part comes up. You'll notice that as I select these points, he's searching for relations. Okay, so he's searching to find relations. And so you can see here he's finding a vertical relation. Here he has the potential to find a collinear relation. If I don't want him to look for relations, I can hold down the Alt key. And by holding the Alt key down, you can see now he's not looking for horizontal. So like when I do that taper, I'll need to turn that off. I'll need to hold down Alt so it doesn't find a horizontal. But for now, I'm okay with him finding those. And we can come back and relax those later. I'll show you what that is if we need to. So this section along here. And then we're down here to the taper. So I'll need to hold down Alt so I can get that taper shape. And then finally, I'm back up to the sketch axis there. Alright, so now what I want to do is start to dimension this. And what I like to do is start with the overall dimension first of all. There are different ways of getting dimensions onto a sketch. One is just to come in here and simply select these two objects. And you can see that I'm getting a suggested dimension down here, but it's a lot larger than the 29.8 millimeters that I need. So I am going to type in 29.8 and then hit enter. And what he's offering to do is to maintain these proportions as I drew them. And if I say yes, he will scale the entire sketch down and maintain the proportions as I drew them. And that's exactly what I want to do, so I'm going to say yes. Alright, and you can see now I have a properly sized and approximately properly proportioned sketch. So I'm going to continue dimensioning. Another way to dimension is to just select a single object. Okay, so here I've selected a single object, and my dimension should be 9, but you'll notice that he put the approximately equals to symbol on there. So that means that it's not exactly 9. So what I want to do is touch on that, double click it, and change it from approximately 9 to exactly 9, and then mash my mouse wheel, and now I have 9 millimeters. I'm going to continue to do that across here. Let's select one object, then another, and this one should be 13.2. I will mention sometimes when you dimension, things will get out of whack. You might get something like this where the lines got moved out of position. While it's still brown like this, you're able to come in and make adjustments as you need to. So notice here, however, he has found a constraint or a relation between these two lines. He's found a collinear relation. So if that's something that I don't want, what I can do is touch one of those lines and I'll see the relations, the symbols for the found relations will light up. If I want to disable those, I can relax them. So we relax them by touching them, and when they're magenta like this, that means that they are relaxed. And what that means is that if I do anything that overrides that collinear relation, then it will delete that collinear relation. So by moving this up, now they're gone. So when I touch this again, you see that there are no relations between those two lines. Now, another way to add dimensions is to actually explicitly start the dimensioning tool. So you can hit D and get the rapid dimension tool, and that's kind of a nice way if you need to just really quickly put on a specific type of relation and you would rather just be explicit about it and ask for these things instead of sort of the guesswork feeling of touching around on your sketch. I need to change this to 15 mm and add another dimension here, this time 15.9. Another dimension here. This one is 24.2. Now, the print that I'm working from has an error on it. Hopefully I've gotten it fixed on the website. But this 3.3 should not be a reference dimension. It should not be in parentheses. That is a required dimension. I either need to know the length of this taper or I need to know the diameter at the small end. So this is not a reference dimension, and I'll get that changed on the website. Let's see. So now we need to dimension these diameters. Later versions of NX, the last few versions, have had a half diameter option, and that's what I'm going to use. I'm going to start by selecting the axis and then selecting the part. Now that's not a half diameter, but if I right click on that and say convert to half diameter, then now I have the half diameter option. So that is now 7 mm. I need to move this so that it's a little bit out of position. And this one is going to be 5.4. Now since I've put the first half diameter on there, if I dimension now from the axis to that surface, it's going to default to half diameters. So that's now 5.4. Mouse wheel. Mashing in on the mouse wheel is kind of like hitting enter. Here to there, another half diameter, this time 4 mm. Whoops. I want to start here and go there. This one is also 5.4. So what we're trying to do is kind of be ridiculous about the design intent and say that since our print has two separate 5.4s, that these have the potential to change independent of each other. So this might wind up being 6 at some point. This might wind up being some other value. Now, whether or not that's valid, that's to take up with the engineer that drew the print. But what we're trying to do is model the actual design intent and show that in our model. Out here to this portion, this is 4 millimeters. And out to here, This one is 1.4. All right. Now we need our taper. So we'll dimension the taper. Notice here that it's dimensioned as 8 degrees, but that is the included angle. We are dimensioning half of that, and so we'll touch this and touch that. We'll drag this down so that it's over here, and this is going to be 4 because that's half of the tapered angle. Now you'll notice it kind of went shooting off into space. That's because this length has not been defined yet. Okay, so I'm going to kind of adjust it down so that we get sort of the schematic of what we want. Remember, when this stuff is brown still, you can kind of move it around. So I'm going to get this where it kind of looks at least in the right shape. And now I'll dimension it. I can just touch the line and choose this horizontal dimension, and that's going to be the 3.3, the one that was erroneously dimensioned as a reference dimension on the print. Alright, so that is our completed sketch profile, and you can see down here it says that the sketch is fully defined, and that is exactly what we want. We'll say finish. Now, since the later versions of NX will automatically select the sketch that we just got through creating. If we don't like that, we can hit escape and it won't be selected. It is actually what we want, so we could keep that. But I'm just going to go through the revolve command and select the sketch. In fact, what I did that time is I selected a single curve, so we don't actually want single curves in this case. We want to select the feature curve. So the feature curve will select everything inside of that sketch, and in this case that's what we want. Then we want to specify a vector. The vector is going to be this x-axis, so we could pick that off of the datum CSys, and since it has a nicely defined point, then the point is already selected. We want to make sure that we start at 0 and go to 360, and our Boolean is none, so we just want to create this. We don't want to combine it with anything else. And we'll say OK. And that is the beginning of our needle valve, and that's another look at the sketch task environment.